Get ready to embark on a thrilling journey through the fascinating world of artificial intelligence hardware. It's no secret, artificial intelligence is making waves in countless industries. And understanding this technology is essential for anybody who wants to stay ahead of the curve. So in this video, I'm going to take you on a personal tour of the hardware developments in artificial intelligence. So we're going to talk about everything from Microsoft's top secret AI chip Athena to Elon Musk's unexpected purchase of 10,000 GPUs for some kind of unknown Twitter project. All after he just said we should take a 6-month pause on artificial intelligence development. So let's start by talking about how the ChatGPT for hardware can make you an electronics expert. So imagine having the power to create your own electronic devices at home. You know, things like a custom snowplow, a quirky Coke can helicopter, or even an awe-inspiring homemade tank. Well, that's what the new chatbot that's embedded in the Flux electronic hardware development kit offers you. So Flux is a highly technical electronics design tool, but with the help of the AI-powered Flux Copilot, you have a personal helper that helps learn about your project. It's like having an expert right there in your design tool. It can help you choose the right parts, give feedback on your schematics, spot errors, and even answer your questions. So you just chat with your Copilot and you'll be one step closer to building that custom mech suit that you've always wanted in your garage. For artificial intelligence, we've entered the world of GPUs and now even TPUs. Let me explain. As AI gets more popular, we see more and more of these customized chips, sometimes called GPUs or ASICs or TPUs, but the point is they're not the standard central processing unit like in all laptops, usually called a CPU. And recently they're being engineered by the really big tech companies, Google, Microsoft, IBM, Nvidia, companies like that, which are basically trying to ingest the entire internet and any other data they can get to train these gigantic trillion parameter models. So in some cases, they're building custom chip designs so that they can build special software that can make a special architecture. In other cases, they're just looking at inefficiencies in their current systems and they're trying to make it move faster. Now, in some cases, you're seeing specialized chips on like your phone and your laptops, but a much bigger portion of this custom design is going into cloud systems, where the big companies want to line up tens of thousands of these chips all in parallel and either train their own specialized models or create some kind of an API, a cloud infrastructure like AWS that you can plug into. So if you're in this space, you might be vaguely aware of the TPU, the tensor processing unit from Google, or maybe even the D1 chip that powers the Dojo supercomputer at Tesla. And it always felt like Microsoft was falling behind the curve, but it turns out they were just keeping it in stealth mode. So it's official now, Microsoft has been secretly developing their own custom ASIC artificial intelligence chip since 2019. Its codename is Athena, and they have been working hand in hand with OpenAI, so that means a chip like this will probably power the next generation of ChatGPT. Now this Microsoft chip was actually made with TSMC as a partner on the 5nm wafer. Now this is a big deal. One, because Microsoft already kind of got a jump in this space. So a super-powered boost might give them like an insurmountable lead. But also because there's a good chance that these chips end up in the Azure cloud, which means other people like us could rent time on them to build something cool. So the rumors are that right now Microsoft and OpenAI are actually playing with these Athena chips. They're up and running in some capacity. Now it's unlikely that the most recent large language model GPT-4 was trained on them, but it probably will be for GPT-5, which does lead me to wonder if that's part of why Sam Altman recently said that they don't have intentions to train GPT-5 right now. You know, it wouldn't surprise me if they're just waiting for this new architecture because it will deliver like orders of magnitude benefit. So some of that's speculation, but it would make a ton of sense right now if Microsoft focused on making sure that they lay the groundwork with GPT-4, getting it into Bing, the Office apps, Microsoft Copilot, their cybersecurity stuff, their designer stuff, then get a feedback pipeline from all of those little tentacles back to the core system. Let that data and ecosystem develop as they're installing these Athena chips, train GPT-5 on all of that, and maybe it'll be game over. So the YouTuber Anastasia Tech brought my attention to this incredible new paper. Researchers have started seriously working with transistors that are made from 1 atom thick graphene sheets. And when I say thin, I mean really, really, really thin. So thin that you have to think about quantum mechanics. These sheets are basically 1 atom thick with little pockets somewhere of 2 atoms. And at that scale, you're basically missing an entire dimension to reality. And that's not woo-woo stuff. Electrons don't really have an exact point in space when you get that small. Like when you get that small, the location where an electron is in relation to an atom is not really a place. It's not a point in space and time. It's more of like a hazy cloud of probabilities. It's more like a statistical thing. It's not even the reality we're used to. The physics allow for a unique ability for it to both store data and calculate data at the same time, which bears similarity to how our neurons work. They both calculate the changes and they store our memories. IBM in the past has tried to work with 2D materials, but it was so hard they actually gave up on the project. But they didn't give up on building specialized chips for artificial intelligence. And as far as AI chips go, let me tell you why that's a good thing. So IBM has now released a new artificial intelligence chip that's specialized in training vast amount of data for big neural networks, like the ones that are powering ChatGPT. So one of the unique things that we're starting to discover is that when you train these huge neural networks on these huge amounts of data, too much precision is actually a bad thing. Because we want them to generalize to so many different problems, it turns out that having a chip that can actually process all of that data in a more general way, a less precise way, is actually a good thing. So the problem with any of the custom chips that like Google and Microsoft has made, or even the GPUs like Nvidia makes, is that they're precise calculations. They take matrix multiplication and they always get the answer right. And it takes a lot of work, a lot of energy to make sure that they are that precise. And that's a great thing when you want a computer to do exactly what you told it to do. And that's why huge industries have popped up around error correction and precision chip making. But IBM's new chip, focusing on the opposite, being less precise but still being generally good, might allow for new artificial intelligence models that require either a lot less power, a lot less data, or the same amount of power and data and much better performance. Alright, but too much theoretical stuff. Let's talk about an actual supercomputer that Google announced that's up and running today and how it compares to Nvidia's best. Now, years ago, Google built something called the Tensor Processing Unit. It's a custom chip that's made for artificial intelligence. And they have arranged more than 4,000 of these little chips together into one big supercomputer, and they announced that it's up and running. It's called the TPU version 4. And they claim that this bad boy is faster and more energy efficient than any other supercomputer in the world when it comes to the specifics of training artificial intelligence. Now, hold your horses there, Google. That might not be true. And that's because in their announcement, they compared it to Nvidia's supercomputer based on the A100 architecture, and not Nvidia's H100, which the details admittedly are a little bit more secret around. But the CEO of Nvidia said that the H100 is 4 times more powerful, meaning that Google would still be in second place. But it might be a little bit of a mystery who's got the top spot, but we definitely have 2 extremely powerful supercomputers that are meant specifically for training AI, which means we can guarantee more progress towards machine intelligence. Now, getting a chip made requires basically a worldwide logistics system, and for national security reasons, the Western powers are trying to lock those chips up. So here's the TLDR on the US versus China chip battle. The US has been putting some rules in place to stop China from getting access to the most advanced chips in the world. So the goal is for the Western powers to slow down China's growth in artificial intelligence and supercomputers. But realistically, the highest end of technology is more of a worldwide system at this point. The supply chain is so complicated that it's unrealistic that one country can be self-sufficient anytime soon. And even though China and America would both like to be completely independent, even with hundreds of billions of dollars invested, it doesn't seem like that's going to happen right away. Now, both countries are trying to spend as much money as they can on research, grow these industries as fast as they can, but it's complicated for any company that's trying to do business in both countries, make money in both places, but also please both governments. And it's from that tension where basically all of the drama comes from. So now let's follow one man's story in the shady underground world of hardware mods, and how Nintendo's relentless pursuit took this man from prison to debt. So there's this guy, he's part of a hacker group called Team Executor.
Team Executor.
And he is now finally getting out of prison after being locked up for 2 years. Now, the hacker group that he led used to make and sell these specialized chips that would let people play pirated video games on older consoles like the Nintendo Switch and the PlayStation Classic. So he's out of jail now, and the 2 years was actually a reduced sentence based on good behavior. But he's coming home to a massive debt because he agreed to pay Nintendo $10.5 million. There's even a second court order that's probably going to make him pay another $4.5 million. Can you imagine that much debt? So far, he's only managed to pay back $175. So be careful what kind of hardware you mod, especially if you start selling it to other people, because some of these companies have some deep pockets. So speaking of deep pockets, let's talk about Elon Musk and his new purchase of 10,000 GPUs for Twitter. I mean, what's that all about? Didn't you say we needed a 6-month pause on AI? So Twitter's got this secret AI project in the works and Elon Musk is all in on it. We know that he's purchased at least 10,000 GPUs to train some kind of a model. So it could be about generative content creation, could be a better user experience, I don't know. Maybe it's the first step towards building Truth GPT to take on ChatGPT, but it's ironically self-serving to see him say, let's ban all high-end artificial intelligence for 6 months until we can get it safe, and hey, take my money, I need all that stuff over here. And the plot thickens because he just turned off the data stream that was going into OpenAI to train ChatGPT from Twitter data, presumably because of this project or his other company x.ai that he just started to compete with them specifically. Either way, I doubt it's the last we're gonna hear about the battle between Elon Musk and his old pals at OpenAI. Smash that subscribe button.
It doesn't end in like a bluff,
Right.
because it creates a low pressure zone behind the mirror.